G'day. The integral you're looking at here is integral number 9 in Jim Coroneos' list of 100 integrals. And integrating inverse tangent functions by themselves is not terribly easy, but we certainly know how to differentiate inverse tangent functions, and therein lies the solution. Because we can treat this as a function multiplied by the derivative of another function and therefore integrate by parts. And that means that although we might be integrating the inverse tangent here, we're going to be differentiating it over here. Let's have a look. Integrating by parts, if this is u.dv, will give us the product of the two functions, x times the inverse tangent, minus the integral, and then here the two functions swap, so the x will come out the front, and we now take the derivative of the inverse tangent. Well, the derivative of inverse tan of x is 1 on x squared plus 1, but here we have a 2x, so it's going to be 1 on 2x all squared plus 1, multiplied by the derivative of the function inside, because we have a chain rule. Derivative of 2x is 2. And you can see that this is a vast improvement on that. Here we have x tan 2x minus, and this, let's write it, 2x on 4x squared plus 1 dx. Now I hope you notice very rapidly that the derivative of this very closely resembles that. That is, the derivative of the denominator would be 8x, and all we have to do is multiply the top by 4, I'll use a dot, and divide by 4 out the front as a compensating factor. So this now is 8x, which is the exact derivative of that. We have ourselves a structure that gives a logarithmic function. So let's integrate. And we get x inverse tan of 2x minus 1/4. Actually, I'm going to write the 4 underneath, of the logarithm of 4x squared plus 1. In this case, I did not bother using the absolute value sign, simply because 4x squared plus 1 can never be negative. So it's rather redundant. And that's our solution. Had we not seen that we could do this integration by parts, we could perhaps have substituted, let u equal inverse tangent and so forth. It would be a longer, harder road, but you would still manage to integrate. But I think this is a neater, better solution and a more rapid one. If you've enjoyed that, then please click the like button and leave a comment. By all means subscribe to find out about the future videos, and I thank you for watching.